Math 1108, Section 7.5, continued applications with rational expressions. Number 5, Lizette can mow the lawn in 3 hours, and Barbara can mow the lawn in 2 hours. Find the amount of time it takes both of them to mow the lawn if they work together. This is a work problem, so work problems have equations of the form rate times time equals 1, where 1 is the job or task that they are working on. Okay, so there are 3 scenarios to consider. Lizette works by herself, Barbara works by herself, and then they work together. We're told that Lizette can mow the lawn by herself in 3 hours. So Lizette works at a certain rate, and in 3 hours, she mows one lawn. Barbara mows the lawn in 2 hours, so Barbara's rate times 2 equals 1. And we're supposed to find how long it will take them when they work together. So Lizette's rate plus Barbara's rate times t equals 1. We're using the variable t to represent the amount of time it takes them to mow one lawn when they work together. So just like in the earlier problems, we'll solve for the rates. Lizette's rate is 1/3, meaning that she can mow 1/3 of the lawn per hour. Barb's rate is 1/2. And the sum of the rates, Lizette's rate and Barb's rate added together, is 1/t. So in this equation, we replace r sub L with 1/3, replace r sub B with 1/2, and those are equal, the addition of those is equal to 1/t. The least common multiple of the denominators is 6 times t, so we multiply every term on both sides by 6 times t. 6t times 1/3 is 2t, 1/2 times 6t is 3t, and 6t times 1/t is 6. 5t is 6, and so t equals 6/5 hours. So when they work together, they can mow the lawn in 6/5 hours, or 1.2 hours, which is 1 hour and 24 minutes. But I'll just say 6/5 hours. Okay, the next problem, number 6. It took Lance a total of 2 hours to ride his bike 12 miles and run 6 miles. Lance's running rate was 10 miles per hour slower than his biking rate. Find Lance's running rate. Okay, so this is a uniform motion problem. The equations will have the form rate times time equals distance. So 2 things are described. He's running for a certain amount of time, and he's riding his bike for a certain amount of time. So run and bike. We're supposed to find Lance's running rate. So we'll use x to represent Lance's running rate, x miles per hour, and we'll represent the amount of time it took him to run 6 miles as t sub r. So rate times time equals a distance of 6 miles. Lance biked a distance of 12 miles, and we're told that Lance's running rate was 10 miles per hour slower than his biking rate. So the biking rate is represented by x plus 10 miles per hour, and t sub b is the amount of time that it took him to bike 12 miles. Okay, in the first part of the first sentence, we're told that the total amount of time to ride the bike 12 miles and run 6 miles was 2 hours. So that means t sub r plus t sub b is 2. Okay, so we'll solve each of the equations for time. The amount of time it took him to run 6 miles is distance divided by rate, 6 divided by x. The amount of time it took him to ride his bike 12 miles is a distance of 12 divided by the rate. And then we'll substitute each of those quantities into this equation, and we'll get 6 over x plus 12 over x plus 10 equals 2. The least common multiple of the denominators is x times x plus 10. And we'll multiply every term on both sides of this equation by the least common denominator. When we multiply the least common denominator by 6 over x, the x's cancel, so we'll just have 6 times x plus 10. And then when we multiply the least common denominator by 12 over x plus 10, the x plus 10 factors cancel, so we'll get plus 12x. And then on the right-hand side, we'll multiply the least common denominator by 2. The least common denominator in expanded form is x squared plus 10x, so we'll multiply the quantity x squared plus 10x by 2. Then we'll do a little bit of algebra and arithmetic. 6 times x plus 10 is 6x plus 60, and then plus 12x, and that's equal to 2x squared plus 20x. We'll combine like terms. Well, I'll just go ahead and subtract both 6x and 12x from both sides, and also subtract 60 from both sides, so that we get 0 equals 2x squared plus 2x minus 60. And then I'll divide every term on both sides by 2 to get 0 equals x squared plus x minus 30. And this factors pretty nicely. The two factors are x plus 6 and x minus 5. The two solutions are to that equation are negative 6 and positive 5, but in the context of the problem, only the positive solution makes sense. So Lance's running rate was just 5 miles per hour. Okay, the next problem. Working together. This is another work problem, so equations in this one will have the form rate times time equals 1. Working together, Edward and Brent can rake a yard in 6 hours. Edward takes 2 times longer to rake the yard by himself than Brent. Find the amount of time it would take Brent to rake the yard by himself. Okay, so they work together, and they each work separately, and we're supposed to find how long it takes Brent by himself to rake the yard. Okay, so when they work together, they can rake the yard in 6 hours. So Brent works at a certain rate, Edward works at a certain rate. So when they work together, we add their rates, and in 6 hours, they can rake 1 yard. We're supposed to find how much time it takes Brent by himself. So we'll write Brent's rate and then use x for the amount of time it takes him to rake 1 yard. And we're told in the second sentence that Edward takes 2 times longer to rake the yard by himself than Brent. So Edward works at a certain rate, and since Brent takes x hours, Edward takes 2 times that, so 2 times x, and then the product is 1. So just like before, we'll solve each of those 3 equations for the rates. Brent's rate plus Edward's rate is 1/6. Brent's rate is 1 over x. Edward's rate is 1 over 2x. And then substitute those 2 quantities into this equation. For Brent's rate, we have 1 over x. We're adding that to Ed's rate, which is 1 over 2x. And the sum of the 2 rates is 1/6. The least common multiple of the denominators is just 6x. So we multiply every term on both sides of this equation by 6x. 6x times 1 over x, the x's cancel, and we're just left with 6. 6x times 1 over 2x is 3. And 6x times 1/6 is x. And 6 plus 3 is 9 equals x. And so that means Brent takes 9 hours to rake the yard by himself. Okay, and the final problem, this one says Corinne rode her bike 5 miles uphill and then back. The rate going downhill was 20 miles per hour faster than the rate going uphill. it took 20 minutes longer to go uphill than downhill. Find the uphill rate. Okay, so we have, this is uniform motion, so equations will have the form rate times time equals distance. And there are two scenarios. Corinne rides her bicycle 5 miles uphill, and then she rides her bicycle 5 miles back downhill. And the rate going downhill was faster by 20 miles per hour than the rate going uphill. Okay, so find the uphill rate. So let's just use x for the uphill rate and t sub u for the amount of time that it took her to ride her bicycle 5 miles uphill. So here's our rate times time equals distance for going a distance of 5 miles uphill. And then downhill, the rate going downhill was 20 miles faster than x, so its rate is x plus 20 miles per hour. And we'll use t sub d for the amount of time it took her to bicycle 5 miles downhill. And then we're told that it took 20 minutes longer to go uphill than downhill. We have to convert 20 minutes to hours. 20 minutes is 1/3 of an hour, but we'll note that t sub u, the amount of time it took her to bicycle uphill 5 miles, that's greater than the amount of time it took her to travel 5 miles going downhill. It's greater by 1/3 of an hour. So this can be converted into an equation. The larger number minus the smaller number is equal to 1/3. So just like we've been doing, we'll solve each of those two equations for time. The amount of time it took her to travel 5 miles uphill is distance divided by rate, 5 divided by x. The amount of time it took her to travel 5 miles downhill is distance divided by rate, 5 divided by x plus 20. And then we'll put those quantities into this equation. T sub u is 5 over x. We're subtracting t sub d, which is 5 over x plus 20. And the difference is 1/3. The least common multiple of the denominators is 3 times x plus 20. Or if you want to multiply it out, it's 3x squared plus 60x. Okay, so we'll multiply the least common denominator by every term on both sides of this equation. When we multiply it by 5 over x, the x's cancel, so we'll just be left with 5 times 3 times x plus 20. And then multiply 3x times x plus 20 by minus 5 over x plus 20. This time the x plus 20 factors cancel, and we're left with minus 5 times 3x. I'll just go ahead and write it as minus 15x. And then on the right-hand side, multiply 1/3 times the least common denominator. Well, if you multiply 1/3 times 3x squared plus 60x, you'll just get x squared plus 20x. And then we'll multiply some things out and combine like terms and so on. So 5 times 3 is 15, and then 15 times x is 15x, and then plus 15 times 20 is plus 300, and then minus 15x equals x squared plus 20x. On the left-hand side, the 15x minus 15x, those cancel each other out. So we'll just subtract 300 from both sides, and we get 0 equals x squared plus 20x minus 300. And this factors really nicely. One of the factors is x plus 30, and the other factor is x minus 10. This equation has two solutions. One of the solutions is negative 30, but that doesn't make sense in the context of the problem. So the other solution, x equals 10, that's the bicycling rate going uphill measured in miles per hour. So that is the answer. It took, or he was bicycling at 10 miles per hour when he was going uphill.